Question 21. In the diagram, line MN is parallel to line KL. This line and this line are both parallel to one another. Line ML and KN intersect at X. That's line ML and line KN, these two lines, meet at X. Line MN is 12, this line MN is 12, and line MX is 10. Line MX is 10. And line KL is 9. KL is 9. If the area of the triangle MXN is 16, MXN, this triangle, is 16 centimeters squared. Calculate the area of the triangle LXK. So we have LXK. You should find the area of this triangle. We know this is a shape with two triangles in it. This is triangle 1 and this is triangle 2. And this question falls under similar triangles or lines that can be equated to one another. This is a smaller triangle and this is a bigger triangle. You can also say this small triangle has been enlarged to this. We know the area of this triangle is 16 centimeters squared, and we're asked to find the area of this. There are three known ways of solving this question, and one of these three ways is a shortcut to solving this question. Now, we know the area of this triangle is 16 centimeters squared, and we're asked to find the area of this. To solve this question, you can use the equivalent method, which is also regarded as a shortcut method, where you have this 12 over the square root of this area equals 9 over the square root of the area of a small triangle. Noting that this is the big triangle and this is the small triangle, we do 12, that's the base of the big triangle, to the square root of its area equals or equivalent to 9, which is the base of a small triangle, to the square root of the unknown area. That's the only way we can equate this to this. This question can be tricky in the sense that some might jump on it and think they will just do 12 over 16 is equivalent or equal to 9 over the area. But in this case, it has to be 12 over the square root of this area, the area of the big triangle, equals 9 over the square root of area of a small triangle. So we have it as 12, which is the base of a big triangle, over the square root of its area, which is 16, equals 9, which is base of the small triangle, over square root of the unknown area which we are looking for. And with this we solve. So we have 12 over square root of 16 is 4, equals 9 over square root of a. You can break this down or we can cross multiply and solve. Is allowed. So you can say 4 here 1, 4 here 3. So we have 3 over 1 equals 9 over square root of a. On the next line we cross multiply, we have 3 times square root of a equals 9 times 1. So we have 3 times square root of a equals 9 on the other side times 1. We divide both sides by 3. 3 cancels 3. 3 here 1, 3 here 3. So we have square root of a equals 3 times 1. Square root of a equals 3 times 1, 3. For us to remove the square root, we square both sides. That's the opposite of square root. So square root is cancelled by square. So we have a equals 3 squared, which is 3 times 3. Our a equals 9 centimeters squared. Our answer is therefore B. Like said earlier, there are two other ways to solve this question. The other two methods I talked about out of the three are quite similar. Using the area of the triangle and taking 12 as the base, you find the height. Then you do 12, which is this line, to the height. Then KL as our base to the height. Then when we get the height, we'll find the area. Since the area of the bigger triangle MXN is 16, that's area equals 16. That's area of this big triangle where you have 10, 12, you have your X, M, N. The area is 16. Then the formula for area is half base times height equals our area. We will take this 12 as our base. As we have half times your base is 12 times your height, which is unknown, equals 16, which is the area. You can say 2 here 1, 2 in 12 is 6. So we have 6 h equals 16. Divide both sides by 6. 6 cancels 6. H is 2 here 3, 2 here is 8. Our height is 8 over 3, meaning the height of this triangle is 8 over 3 centimeters. What we're going to do now is we'll say 12 over 8 over 3 is equal to or equivalent to 9, which is also the base of this, over its height. To find the height, we cross multiply and find the height. So we have 12, which is the base of this triangle, over the height is equivalent to this of a similar triangle that's the base of this to the height. Then we'll find the height. After we find the height, we use the height and the base to find the area. At this point, we want to equate the base of this over its height to the base of the smaller triangle to the height, which is unknown. So we have 12 over 8 over 3 equals 9 over x. This is our x unknown. On the next line, we'll cross multiply. Don't worry too much about this 8 over 3. It's not going to really affect you if you're very good at your fractions. Let's cross multiply. So we have 12 times x equals 9 times 8 over 3. So we have this 9 multiplying this 8 over 3 and this 12 multiplying this x. On this side, we can break it down. You can say 3 here 1, 3 in 9, 3. Then we have 12 times x equals 8 times 3 is 24. We divide both sides by 12 to find the value of x. 12 cancels 12, 12 here 1, 12 here 2. X is 2. We now know for the smaller triangle, the height is 2 and the base is 9. With this, we can now calculate the area of this small triangle with the base 9 and the height 2. So we have it as area is half base times height. Our area is equals to half base is 9 times your height is 2. We can say 2 here 1, 2 here 1. Area equals 1 times 9 times 1, which is 9. Our answer is 9 centimeters squared. Our answer is same as using the first method, which is B, 9 centimeters squared. It's about using the area to either find a side of this bigger triangle. Once you have the side, you can equate it and find this side and also this side. This side has MN, which is 12, is similar to KL, which is 9. MX is similar to XL, and XN is similar to XK. Then we use these three sides to find the area of the triangle.